Good evening, everybody, and welcome to this Philosophy Live event about living in the past, memory in humans, machines, and artificial intelligence. And welcome to those of you here in the theatre and also to our online audience. My name's Ali Boyle, and I'm a philosopher here at the LSE. And a lot of my work is about understanding the mind, including the different kinds of minds that exist in humans, animals, and possibly AI systems, which is an area that several of us work on in the LSE philosophy department. And today's event is about a particular aspect of the mind, which some people have argued is uniquely human, and that is memory, and more specifically episodic memory, which is the memory capacity that enables you to relive and reminisce about past events. So, for example, if I asked you to cast your mind back to this morning and think about having breakfast, you probably will find that you don't just know what you had for breakfast, but you can call that moment to mind. You can picture it in your mind's eye, you can see what you had, how the room was arranged, what was going on around you. You might also be able to hear things in your mind's ear or smell things in your mind's nose. And that ability to relive and recall specific past events seems to be a very important part of life for many humans. We seem to spend a lot of time thinking about, dwelling on, or reminiscing about past events. And some theorists have argued that that's even part of what makes humans unique, and that humans are the only animals that do this, and all other animals are stuck in time. But it's not totally clear why humans spend so much of their time reminiscing about past events, whether this is even a good thing. Maybe we should spend more time living in the moment. And there's a lot of debate about whether this really is uniquely human, or whether some other animals and maybe even machines can think about the past in this way. So, to talk about these issues, I'm delighted to be joined by four leading researchers of memory, whose work investigates memory from a lot of different perspectives. So first of all, Clayton is a comparative psychologist based at the University of Cambridge, whose work has transformed our understanding of memory in non-human animals, especially birds in the crow family. Johannes Mahr is a philosopher and cognitive scientist based at York University in Canada, whose work has investigated the role of episodic memory in human social practices. Felipe De Brigard is a cognitive scientist and philosopher based at Duke University in the States, whose research investigates the relationship between memory and imagination, among other things. And Zafeirios Fountas is a research scientist specializing in brain-inspired artificial intelligence at Huawei, who has looked at building memory into machines and how that could improve AI. So thanks to all of you so much for being here today to talk about memory. We're going to have a panel discussion, so we'll start off by asking you all some questions before turning it over to the online and in-person audience to invite questions. And I'll let you all know when I'm opening the floor. But for now, let's just get started with some initial questions. And I want to start with Felipe. So Felipe, your work, among other things, I said, has looked at the relationship between memory and the imagination. Why do you think these capacities are related?
So I started working on memory from the point of view of false memories. I was particularly interested in the fact that we constantly and systematically falsely remember things. And the thing that interested me was not so much the frequency with which they happen, but the fact that they were very systematic, that we tend to have, that there's a sort of underlying logic to the kinds of things that we false alarm. And it just led me to think about ways in which I could build computational models to try to understand how our background knowledge influences the way in which we falsely recall events. And one way in which I ended up thinking about it is, look, our memory system is trying its best to retrieve the information that it had at encoding at the time of retrieval. It's incomplete, it's gappy. We have a system that allows it to complete it that way. And the kinds of models that I was building was sort of thinking, your memory system is trying to come up with the best possible answer of how is it that the past could have been. And I started thinking, well, this is kind of like an unconscious counterfactual. That's like what your memory systems try to give you the best possible estimate. And that just led me to think, well, maybe our capacity to think about what could have happened is also underpinned by the same sort of mechanisms. So they're profoundly intertwined, in my view, because they are trying to solve very similar computational processes.
Interesting. So would that suggest that then the episodic memory is just a kind of imagination?
With certain addendums, yes. So we tend to think that if something is a cognitive process, then it is uniquely a cognitive process and it is not associated with other additional sort of processes on top. And I think that episodic memory is a kind of mental simulation with a particular additional metacognitive process on top that it says not only, hey, this is something that it is very likely could have happened, but also there's the metacognitive judgment that, yes, it did happen to me. So every mismatch and every malfunction at those different stages elicits a different kind of memory experience.
Great. And you mentioned memory errors have been very important in making you think this way about memory. Could you say a bit more about what kinds of memory errors you have in mind? Like, what are the ways in which memory
So memory
can
can fail in lots of ways. Like, for instance, if you park your car in the same parking lot during 15 years working in the same company, you're going to misremember where you park it often because all the rooms are going to start looking very similar and so forth. That's a kind of memory error in which your memory system is trying to sort of compile a whole bunch of information and make it really effective. That's why people have assigned, one of the reasons why people have assigned spots. If people didn't have assigned spots, then there's going to be a mess. Everyone is going to be like clicking to see where their alarm is sounding. The kinds of memories that I was interested in is, the best example is to use an illustration. We often falsely remember whether, say, a car failed to stop at a stop sign or a yield sign, for instance, but imagine that the traffic sign was a very unusual traffic sign. So I did this experiment years ago in which we presented participants with kangaroo crossings in North Carolina. Not a whole lot of kangaroos in North Carolina. So you would imagine that if you have seen that sign, the chances that you misremember having seen that sign is really, really, really low. So you can actually plot that in a distribution of the frequency with which you see different kinds of traffic signs. And the thought is, when you have had lots of experiences with the stop signs, very likely that you're going to misremember a sign for a stop sign. But if you have never really had many experiences with kangaroo crossings, then it's very unlikely that you're going to false alarm to a kangaroo crossing. Those are the kinds of errors that I'm talking about, in which the frequency of prior encounters drive the way in which your memory comes to you. And for the most part, they work fine. But sometimes you have errors, and the errors are perfectly predictable given that model.
Great. So this feature of episodic memory, where it's subject to all of these errors, some people have argued that because episodic memory is so error-prone in that way, it's not actually a very useful kind of source of information about the past. And some people have argued that actually remembering the past is not a particularly useful thing at all. Johannes, you in your work have looked at the evolution of episodic memory and looked at why creatures like us might have evolved this tendency to remember and think about the past in these ways. Where do you think this tendency that we have to recollect the past in these error-prone ways included comes from?
Well, I think first of all the question is ambiguous because episodic memory, as Felipe already mentioned, is a very complex capacity that it seems to us sometimes as if it was this holistic, simple thing of just recalling a past event, but actually it has a lot of different parts. And when we ask about the evolution of this capacity, it makes sense to ask about the evolution of these different parts. And I think a lot of the time this is not being done, and then big claims are being made about uniqueness of certain capacity of this capacity to humans, even though some parts might be unique and not others. My work has particularly focused on some of what Felipe already mentioned, these metacognitive aspects of remembering. So when we remember a past event, we don't just recall an event, we also recall all sorts of judgments about our recall of the event and about the event itself that aren't actually part of the event. And one very prominent, at least when you think about this philosophically, very prominent aspect of remembering is what philosophers call sometimes meta-representation. So when we remember an event, we don't just remember the event, we also somehow represent the fact that we are currently remembering. And there's some mental content that goes along with this meta-representation, namely that we somehow know that our past experience of this event allows us now to be able to recall the event. And in some ways you might think that is actually what cognitively, when in the act of remembering, distinguishes remembering from imagining. Because when I'm imagining an event, I might also imagine something that happened in the past at a specific time, but I don't think about it as having been caused by my own past experience. So you can think about this, for example, with an example. So if you imagine your 6th birthday, I personally can't remember my 6th birthday, but I know a lot about the things and the environments and the people that might have been present at my 6th birthday. And it's not absurd to think that from all of this knowledge, I might be able to construct an imagination of my 6th birthday that's more or less accurate. Maybe my mom told me about what happened on that day. And so I have kind of an accurate representation of my 6th birthday. But something's different about my imagination of that event than it would be when I remembered that event. And that goes beyond whether it's accurate, whether it's about a past event, and so on, whether I have some mental imagery. And I want to say, that's what I've argued in my work, that's what I've been interested in mostly, is that this difference is that we have some sort of metacognitive representation about the fact that in a memory we think that our past experience caused us to now be able to actually remember this event. And if I imagine my 6th birthday, that's not the case, because I know, even though I've experienced that event, somehow the connection to my past experience has been lost. And so I've thought a lot about what this meta-representational aspect of remembering is for, what the evolutionary function of it might be. And I feel like maybe I've gone off track and not answered your question.
Well, tell us more about what you think the evolutionary function of that might be.
Well, I got interested in remembering because of this meta-representational aspect, but also because I was really deeply interested in the ability of humans to communicate to each other. This is something that humans do more than any other species, at least in this very prolific way. And in my mind, this meta-representational aspect of remembering must have something to do with this capacity to communicate. And one hint here for me was that so much of our knowledge doesn't come from our own experience. So even though we go through the world, we experience all sorts of things, and we learn from our own experience, a lot of what we know comes from the experiences of others or the testimony of others. And so it might be very useful to be able to distinguish what of our knowledge comes from our own experience, which is what we can remember, and knowledge that doesn't come from our own experience. For example, my mom's testimony about my 6th birthday, and tagging or tracking cognitively the kinds of mental images that come directly from our own experiences and distinguishing them from the kinds of things that we can imagine based on what we know, but not based necessarily on our own experience, becomes really useful for a species that's so reliant on the testimony of others. And that's sort of the theory of why we have this meta-representational aspect.
Great. So we've talked a little bit about memory and the imagination, how these things are related, and that's hopefully helped to kind of crystallize what we're talking about when we talk about episodic memory. So we're talking about being able to remember and kind of reconstruct details about past events and maybe know that we have these representations because we experienced them in the past. So with that kind of sense of episodic memory in mind, Nikki, you've done some very important work exploring to what extent we can find aspects of this episodic memory capacity in animals. What First of all, what kind of motivated you to start looking for this kind of memory in animals? And why was there a question about whether animals even have this kind of memory in the first place?
Well, my original background is in zoology. So I've always loved animals, particularly birds. I've always wanted to be a bird, actually. I have invisible wings. You can't see them, but they are shimmering a little bit in the background. And that's actually what drove me both to my scientific career, where I went to Oxford to study zoology. I wanted to study zoology and psychology, but Oxford doesn't do that, so they made me choose. And the moment my mentor, Lord John Krebs, said, I'll take you bird watching and you can do a research project on bird behaviour, I was like, right, I'm doing zoology then. Although I did take several psychology classes as well. And it also drove me into my other career, which is a dancer and choreographer, because I wanted to move like a bird and to fly. And I don't mean in an aeroplane, that's relatively easy, but to actually feel the wonderful flow of movement when you do a series of chaîné turns across the room or something. So that's really, for me, how it started. And I was very surprised to discover that psychologists said that episodic memory, this experiential memory that we've been talking about, this projection of the self in time back to the past and forwards to the future, was unique to humans. And I said, well, how do you know that? And they said, well, there's no reason why animals would need episodic memory. And in fact, my first discussions were with Professor Tony Dickinson, who years later we've collaborated for years and become very close friends. And he said, well, there's no need for animals to have a memory of the past. They could acquire information about the past, so they could remember that this lever gives food and that one doesn't give food, but they wouldn't have to have an experiential memory of what had happened, this metacognitive awareness that I actually remember it was this lever, as opposed to, I don't really know how I know it, I just know that that one gives me food and that one doesn't, right? So that would be just a feeling of familiarity that I don't really know the source of the information. I don't own the memory, if you like. That's part of the metacognitive bits that we've been talking about so far. Felipe and Johannes, this awareness that it's my memory, I own it. And I said, well, absence of evidence isn't evidence of absence. So just because you don't know they don't have it, I don't think you should just say they don't have it. It needs to be tested. And they said, well, don't be ridiculous. There's no reason why they need it. I said, well, as a bird watcher, and at the time I just moved from Oxford to the University of California, I said, there's loads of scrub jays around campus. Scrub jays are a bit like Eurasian jays, but they're blue and white and they're smaller. And I said, they're always hiding food, and they hide lots of perishable foods as well as nuts. And they're always mucking about and stealing food from others, other jays, but also other animals, including humans, because we are animals after all. We may be different from other animals in many respects, and that's a different topic, but we are animals. And I said, you know, they keep track of what items have been hidden where and when. Do you think if we could show in controlled laboratory experiments that they could keep track of what happened where and when, couldn't that be behavioural evidence? And Tony Dickens said to me, oh my goodness, I hadn't thought of it like that. Well, let's collaborate. And that began in 1996. And years later, sure enough, we showed that they remember what happened where and when. And I refer to, there's a lovely Gary Larson cartoon, which I particularly love to use when describing this, because in the cartoon there are all these animals gathered on the forest floor, and the caption at the bottom of the cartoon is, all animals to this very day remember exactly where they were and what they were doing when Bambi's mother was shot. And you know, the snake says, I was under a rock getting ready to shed. And I said, well, if Dr. Dolittle were fact, not fiction, and the animals really could talk to us and tell us what they were doing when a particular event happened in a particular location, in other words, recalling what happened where and when, then that would be, for me, an example of episodic memory. But of course, as a good, hopefully a well-behaved scientist, although friends do call me Naughty Nicky, I ought to admit that right now. But as a well-behaved scientist, of course, I have to acknowledge that that's purely a definition based on behaviour. It doesn't address these phenomenological issues about being aware of being the owner of the memory, the one that made the memory, the one that wrote the memory, as Johannes was talking about, or this metacognitive reflection that I'm aware that I'm in the present, but I'm casting my mind back into the past, the kind of metacognitive things Felipe was talking about at the beginning. And I don't know how to study those aspects of phenomenological consciousness in the absence of any agreed behavioural markers in non-linguistic animals. But it seemed to me that trying to think about behavioural criteria was an important first step, because at least it would make it empirically tractable, that we could then actually test animals and say, could they remember what happened where and when. So I think that's how I got into it.
This is so interesting. Could you say a bit more about how in the lab you looked at whether the jays were remembering what happened where and when?
Certainly. So I used the fact that they hide food. We call it caching from the French word cacher, to hide, but they're obsessed with hiding food. So is my cat, but that's another story. He's hid my husband's wedding ring 18 months ago, and we have yet to find it. But they're obsessed with hiding food, and because they hide both perishable foods and non-perishable foods, I could build time into the equation. So we gave them nuts, which they like, and we gave them waxworms, which are these yellow, juicy, sort of like really fat, lipid-rich mealworms or earthworms. But they're the Belgian truffles of the corvid world. I've worked with many species of crows, and I have yet to find a crow that doesn't go absolutely ballistically mad for waxworms. They love them. So we let them hide the waxworms on the peanuts. And an important aspect of this work is that all the birds were hand-raised, and I'd had them since they were babies, from before their eyes opened. So I was able to know that they hadn't had any prior experiences. And that's very important for what I'm going to briefly explain now. So we let them hide peanuts and worms, and then they're given a series of sessions. Actually, they learn very rapidly, so they just have 4 sessions, which they then get their trays back either a short time later or a long time later. And in order to make sure that the kind of time we're talking about is the kind of time we talk about in episodic memory, I had it as 4 hours later on the same day, or 4 hours later, 5 days later, so that we were controlling for circadian rhythm. So they couldn't be keeping track of time by just having some sort of biological clock mechanism. They had to actually remember, because it was the same time of day. So 4 hours on the same day, or 4 hours 5 days later. And one group of birds found that the worms were fresh after 4 hours, but they degraded and were horrible after 124 hours, so 5 days and 4 hours later. And we know they don't like them because they spit them out, and they do this with their bill, this aversive thing to get rid of the horrible taste on their bill. So they learn a short delay later, worms are yummy, so it's worth me hiding them and I can get them back. A long delay later, the worms are disgusting, so I'm only going to recover the peanuts. And then we had a control group for whom the worms were always fresh. And that was just during training, so they get 4 experience of, after a short delay, what happens. I get my peanuts and my worms back, they're always fresh for both groups. After the long delay, I get my peanuts and my worms back. For the control group, they're fresh. For the other group, they're decayed and horrible. And then they get the memory test. And in the memory test, they just catch as normal. But now there's no food when they come to recover it. They're not at all happy. They fling the sand in the trays across the room and try and pet the experimenter. They're clearly annoyed that all the food's been stolen. But you can therefore show that their searching is based on their memory of what they had cached where and when, as opposed to simply being able to smell it or any other cues emanating directly from the food. So that's kind of how we started the experiments. And since then, we've gone on to do other things because we've said, well, this is something that Johannes was hinting at in the answer to Ali's questions, that there are other features of the behavioural aspects of episodic memory that one could test. So, for example, this idea of what's sometimes called incidental encoding, that there's the other information you were talking about, your 6th birthday party, for example, and you can't remember it, so there aren't these other cues around, but if you'd had a memory of your 6th birthday, or if we share our memories of when we met just before this event, there'll be things that were nothing to do with the things that were important for us to know at the time that we just happened to remember. For example, I happened to remember where I sat in the room and that there was tea and coffee facilities on my left. There was no reason to remember that. I just happened to remember it. And later on, because I love shoes, I'll probably remember that Johannes was wearing white trainers and that you had rather lovely blue shoes on and that you had black shoes on, for example. So and Ali has sort of black and white bits on her shoes. And again, they're incidental features. So most recently, in fact, a paper that was published last week, we showed that the J's can also incidentally encode features of an episode, a caching episode in this case. Not that they were trained to remember or they needed to remember in any way, but they just happened to remember that some pots had stripes on them and some had lines on them. And then the third kind of evidence we've been looking at, and we haven't published it in the crows yet, but we have in the cuttlefish, because I also work with cephalopods, is the source of the memory. And that goes back to some of the things that you were talking about, Felipe, with the metacognitive representations. Did you read it in a magazine or did you hear it on the radio? And in the case of the cuttlefish, we asked them, did you see it or did you smell it? And in the case of the jays, it's did you see it or did you hear it? Because jays, like us, are very good in the auditory domain as well as the visual domain. In fact, they're fantastic mimics, so I know that they're really sensitive to sound. So those are other ways of trying to get at some of these behavioural features. I don't think we can ever tackle the philosophical arguments about do they have a sense of self and how would we know about the subjective nature of temporal representations in the mind, but I do think we can get at some of these behavioural criteria.
This goes quite nicely into what I wanted to ask you next, which in a way you've kind of anticipated. So you drew this distinction between behavioural markers that we can look for in the lab and this more contested issue of the experiential nature of what's going on with animals' memory. Do you think that's like an insurmountable problem? Is it just a case of us all getting on the same page and agreeing what the evidential standards are? Or is there a kind of deeper problem with us ever drawing a conclusion about whether animals are actually kind of casting their minds back in the past the way that we do?
Well, I think there's a deeper problem in the sense that we will never know, or I can't imagine a behavioural test to do it. On the other hand, as somebody that's really interested in behaviour in all kinds of animals, including humans, there is one card I think we can play. I don't think it's a get out of jail free card, but I think it is a card we can play, and that is the idea of converging evidences to bear on a problem. So I think that if we can show that the kinds of behavioural tests that we do with the animals, who by definition are non-verbal or non-linguistic, that we can also test them in humans and get similar results, then I think we can at least say we seem to be testing the same thing. It doesn't get over the phenomenology problem, I don't think. Mm-hmm. But I do think that, for example, if you look in young children, there's a very tight developmental trajectory. Children aged 3 don't seem to have episodic memories. They don't show any understanding of yesterday and tomorrow as opposed to today. And there have been a whole suite of studies that have been done on this by many developmental psychologists, and my team have also worked on these issues. Age 4, they start passing, and at age 5, they're much better at it. And the transition between age 4 and 5 is interesting because it seems that particularly if you think about the future, and we haven't talked about that yet, but another hallmark of episodic memory is that I think most people now would agree that it evolved for the future, and that episodic memory and future planning, or episodic imagination into the future, goes hand in hand. And you see in young children that they're able to imagine what another little boy or girl just like them will want in the future before they can imagine what they themselves will want in the future. And that's probably because when we talked about the meta-representations, that these things are interrelated, as you both said, it's not a single facet. And one of the difficulties about the future is that you have to ignore what you want right now, sometimes, in order to make the decision for what you want in the future. And if you don't believe me, just try going grocery shopping when you're in a hurry and very, very hungry, and you'll see what I mean. But you'll then stack the trolley with loads of things you want right now and forget about the salad and the things that, the washing powder and the things that actually you do want for the rest of the weekly shop. And so that gets at another of these things that's quite difficult, which is that sometimes your choice has to be, I need to inhibit the response to something right now in order for something better in the future. And actually the jays are remarkably good at that. And so are the cuttlefish. You know, if you give them, there's a famous test called the marshmallow test, which was developed for children, and you can have 1 right now, or if you wait a little while, you can have 5 later. Children are not very good at this, but the cuttlefish and the jays are really good at it. So I think those kinds of converging evidences help to address the problem, but they don't get rid of the hard problem, which is that you'll never be able to test.
Yeah, brilliant. So Zaf, you've also done work looking at episodic memory in another kind of intelligence, artificial intelligence.
Yep.
Could you tell us a bit about that? Like, what led you to look at building episodic memory into AI systems, and what happens when we do?
So first of all, I didn't start with memory at all. I started by doing a postdoc on how to understand how perception of time occurs in the brain, and how by understanding that and building a similar mechanism into robots, we are able to, we could potentially have a more like human-like interaction and more like a collaborative interaction with robots. That even today AI has a big problem with that. You see, for example, that things like big, large language models like ChatGPT are very good in things like interacting with you in language via chat, but when it comes to real-time interaction, to know when exactly they have to stop listening to you, or how to move, if we're talking about a robot, in a way that it's harmonized with you, there is a big problem. And we started with that, and we quickly realized that these two concepts, time perception and episodic memory, are so closely intertwined that you cannot really understand the one without the other, at least from the computational neuroscience perspective that we were investigating that. That led us, and me personally, in my own work, to build models of episodic memory. And after being introduced in this world, I realized that it's such an important aspect of cognition that, without being an expert at all, I would be very surprised if animals didn't have episodic memory capabilities, because especially the ones that exhibit intelligence to any degree close to what we call intelligence. I mean, I don't know how else they would do it. For example, a very important concept that in artificial intelligence that I don't really know any other mechanism that works well apart from some naive implementation of episodic memory is what we call avoiding catastrophic forgetting, or what we call like allowing continual learning, like having models that learn continuously. For example, again, language models today, you see that you have some interaction with them and then they forget entirely what you talked about and then you have to start again. Or they might remember, like they have a large working memory, something similar to working memory. They remember like previous interactions, but just in terms of text. They haven't like experienced previous interactions. If we had, let me actually give you another simple example. Let's say that we have an AI model that we want to train it to understand digits, like handwritten digits. If what we usually do is we take many examples of handwritten digits and we present it to them. And these examples are, let's say, uniformly distributed, almost equal number of examples for any digit, right? And we give them like randomly such that the model sees multiple examples of all the digits together. If we didn't do it like that, and for example, if we initially presented only 2s and then only 5s, when it's trained for 5s, it would forget the 2s, if that makes sense. Mm-hmm. And the real world is not like that. We don't have like equal distribution of the data we receive from the environment. So both us and animals, if we didn't have an ability to remember specific data that were important for us in order to train our behavior, then we would forget that and we would have to train to learn it from scratch. So that's why that's quite important. Yeah, I would say.
Great. So one thing we've talked a little bit about is the ways in which human episodic memory is kind of fragile and friable and error prone. If we're thinking about building episodic memory into machines, should we try to reproduce the error-prone nature of human episodic memory? Is there any advantage to doing that? Or should we think instead AI memory would just be like a perfect, better version of episodic memory?
Well, I don't think that we should try to build exactly the same mechanisms we see in the brain. There are many differences. Let's start from that. For example, we don't have the limitations that the brain has, in the sense that we don't have to build parametric models that are bounded by the computational capacity that the brain has. For example, if we run out of memory, we can have a second hard drive or a second RAM module in our computer, right? On the one hand. On the other hand, listening to you guys in the beginning, and from your question, I don't really find this ability, this feature of memory to forget a few things. I don't find it a flaw. I find it a feature, right? At least from our perspective, that we're trying to build intelligent machines, you need to somehow combine the knowledge that you capture from the environment with new, more exploratory things that you're trying to incorporate and be able to produce counterfactuals, for example, from the past. Like, if this didn't happen, the other thing happened, how would have I reacted? So that's quite important. And also, you use this sort of information to plan for the future and to do mental time travel in the future and be able to I would say, reason about the situation that you are right now, or to create new different scenarios in your head and allow you to act accordingly. I think even dreaming, for example, at least from what we see in artificial models, is very closely related to this, like how you combine previously recorded episodic memories to things of like your semantic memory, what we call like imagination, right? And how you build different scenarios that would help you learn how to deal with situations without having experienced these situations.
Mm-hmm. Yeah. So even in AI systems, there's this important link between memory and imagination, it seems?
Yeah, absolutely.
And did you say that there are computational models that dream?
Yes, actually.
What does that mean?
Good question. So I'm not an expert in human dreaming or animal dreaming, but one of my favorite agents, reinforcement learning agents, which are basically AI models that can act either in a simulated environment or in a real environment. For example, AI models that control a robot, is called Dreamer. And what it does is basically collects information from the environment, from real-time interactions, assigns this information into a buffer that I would say is the corresponding thing to episodic memory from this aspect, and then creates these mental simulations using this information. For example, starting from ground truth information from things that experienced in the past, and building imaginary scenarios without having to interact with the real environment. And we see that this model beats many, many other proposals. And especially if you enhance this model with other aspects of episodic memory, which is some part of work that we have done in the past in our lab, you see that this improves performance compared to other AI agents way more. And you can learn how to, for example, control a robot that is a very complicated robot with very few minutes or hours of real world interaction, close to what humans do.
Brilliant, that's super interesting. So just a kind of general question for anyone who wants to pick it up based on the sorts of things we've been talking about. Do you think there's any truth to the idea then that episodic memory is part of what makes us human?
I want to clarify something because
Yeah.
I feel like maybe I've been misunderstood as saying episodic memory is entirely uniquely human.
Mm-hmm.
I think some aspects are uniquely human, and I think it would be surprising if that wasn't the case. Simply because episodic memory, as Ali pointed out in the intro, plays such an important role for us socially. It's, many people think their memories define who they are, define their relationships, but even more than that, in many cases, episodic memory makes it really possible to stand in certain relationships in the first place. So, for example, imagine promises. If you couldn't remember what you promised, or that you promised, or that you were promised, it would be really hard to make do on promises, which obviously interacts with our linguistic capacity for communication and so on. But I just think it would be very surprising if these kinds of functions that episodic memory has for us wouldn't have impacted the functionality of the system in some way, either through our development and cultural learning, or through longer time, over evolutionary time, through different selection pressures. So I think we should expect some aspects of episodic memory to be uniquely human, but I agree that we should also expect the biggest part of episodic memory to be shared with other animals, simply because it plays such a foundational role in many other cognitive systems.
There is another way of phrasing that question, which is there is something that is uniquely dog-like about remembering things as a dog. There is something uniquely corvid-like about remembering things as a crow, and so forth. One thing that is important not to overlook is there is a difference in evolutionary history among all of us, including AI agents. And the thing that we are aware of, the contents that we are aware of, are extraordinarily different across different species, not only because they're attuned to different sensorial components, so corvids presumably have some kinds of sensory components that are very different from ours, but also because all these other parts that affect our recollective capacity, like metacognition, working memory, are also extraordinarily different across different animals, and non-human and human animals. So perhaps what explains the difference of what it is like to remember something episodically as a human versus as an AI agent versus as a corvid is something that has to do with the kinds of contents that reach consciousness at a certain point. We have, in my work, I have argued, and I think that you agree with me on that one too, that we have a particularly long and protracted amount of content that we can be conscious of, and what William James called the spacious present. And a lot of that has to do not so much with episodic memory, but with the delay with which the content can be deployed in our conscious mind. Mm-hmm. Other animals might have much shorter memories, working memories, might have mental contents that are sensory and extraordinarily different from ours. So they could have been having these conferences and said, like, do you think that episodic memory is what make corvids corvids, or what make dolphins dolphins? And said, yeah, but I bet that there is something that it is like to have a human-like episodic memory. And ultimately, the argument is that differences in contents and difference in ways in which those contents reach consciousness affect the way in which the episodic memories are experienced.
I think another thing to think about is variation in people. So as you're talking about those sort of social interactions and the longevities of memories, I'm thinking about people that have highly superior autobiographical memory. They often refer to it as HSAM, so highly superior autobiographical memory. And these people, it's relatively rare, but these people have incredibly accurate, long-lasting memories, much more accurate than normal people. So what you see with most people is if you ask them to recall an event they experienced a few minutes later, it's very accurate, but then over a few days it declines, and we remember aspects of it, but a lot of the rest of the details just become fuzzy, then no longer important to us, and we move on. But people with HSAM remember the minutiae of the detail. The most famous one is called AJ or Jill Price. She's the one that's been studied the most, but there are others. And I think that because it's also all about social interactions, each case is a bit different. But in Jill Price's case, she's had real problems with maintaining social relationships because, in a sense, she's so bothered with the minutiae of details about the past that she's constantly looking that way, not this way, assuming I'm talking largely to a Western audience for whom the future is there and the past is there. It's not true in all disciplines. I'm a yogi, and in yoga, that's the future. This is the past, because you can see the past. You don't know what the future will be like until it arrives, and then it's no longer the future. But I think cases like that are quite interesting. And in fact, when she was married for a brief period, she coped a lot better, and then tragically her husband died suddenly after about 2 years of marriage, and then all the anxiety came back again. But my understanding of it is that it's almost like an obsession and OCD, a compulsive disorder, you know, like people that can't stop washing their hands, except with respect to memories of the past. And of course that then has all kinds of implications for social relationships. You know, imagine you have a tiff with your loved one, and, you know, a few minutes later, hopefully, you make up and go, oh, sorry, darling, I was an idiot, I really didn't mean that. But imagine if your partner remembers the minutiae and years later is going on about how stupid what you were and how rude you were when you said this really silly thing. You know, it must be really, really tricky. You know, you can see why there are benefits to being able to forget things, because you then just hold on to the important ones. So I think that's quite an interesting aspect of this as well, that you can have these people that have such detailed memories. And I don't think any of them would say that it was a blessing, even though it might be tempting to think, wouldn't it be amazing to have this incredible memory and never forget things? People that do have these highly superior memories don't think it's a blessing at all.
So in my opinion, I really don't think that episodic memory is uniquely human. I think it's we're talking about a spectrum that likely has some identical underlying mathematical principles, but the implementation is very different. So I do agree that it must be very different to what you said, like what it feels to have episodic memory as a human or as any other animal or as an AI. And I think that that's reasonable because all these examples have very different subjective experiences. Even when we talk about phenomenology, I think even modern AI systems, to some extent, we could say have their own subjective experience, because they have their own like latent representation of the world, and they perceive things as like mathematical entities, which doesn't sound very different than what brains are doing, with very different implementation, of course, and hardware. From this aspect. So yeah, I would say that episodic memory might not be uniquely human, but the extent that we have it and how efficient it is in us is unique, and the way that we interact with episodic memory, so far at least.
Great, thanks. I mean, I could keep monopolizing this discussion, but I think this is a good time to turn over to the audience, in person and online. So if you're in the room and you have a question that you'd like to put to the panel in general or someone particularly, please raise your hand and a microphone will come around to you. If you're online, please type questions into the Q&A box, and my colleague in the room will read them out to us. Please include your name if you do, and let us know if you want to direct your question at a particular person. So to begin with, the gentleman about halfway back in the denim.
My name is Rafael. I'm from Santiago de Chile. My question regarding the way you interpret the functional purpose of memory across different species. It seems to me that a criteria would be one to be teleological, in the sense that they advance a necessary function of survival. So we're looking backwards to how does memory, when we forget something, or when an animal forgets something versus recalls it, does it advance its survival prerequisites? In the sense, is it teleological? How does that land on you? Anyone in the panel?
Great. Thanks, Raphael. So summarizing, I think the question was, how should we think about forgetting and remembering in an evolutionary context? So does forgetting affect what we should think about the functional role of episodic memory? Is memory malfunctioning when you forget? Does anyone want to jump in?
So the one thing that just pops to mind, there is a very strong phenomenon in memory called retroactive interference, which is that when you have you encode a set of information, and then immediately after you encode another set of information, the probabilities of you recalling very well information from the first list without contamination from the second list is very low, right? One of the reasons I think that we have rapid forgetting is to prevent this kind of conflation. Imagine that when you were talking about the AJ and individuals with highly superior autobiographical memory, it reminded me of an Argentinian author, Jorge Luis Borges, who wrote a very famous short story called Funes de Memorias. And Funes was a campesino in the Argentinian Pampa that fell off a horse, and as a result of that, lost his capacity to forget. And people would say, like, oh, it would have been amazing to be someone like Funes, because he can remember everything. But the whole story is that within 6 days or so, he went nuts. Like, he just had to change his concepts, like, his entire mind completely changed. And he lived an extraordinarily miserable life until he died of some other non-mental complications. And that, for me, was extraordinarily telling how important forgetting is. And just, this is one instance in which forgetting is evolutionarily advantageous. If you cannot, suppose that, going back to the example of the car, every time that you park the car, you sometimes you park in the first floor, you park in the second floor sometimes, in the third floor, you park it in different areas of the floor. Imagine that each one of those representations came to you with the exact same strength and vivacity. You wouldn't find your job. Suppose that you don't have alarms and thing. You wouldn't be able to find the car. You need the decay of the memory. You need to be able to have a system that somehow is not going to interfere. And because we're temporal creatures, and we somehow need to be able to mark the time off, as it were. if we didn't have forgetting, we will be a mess constantly because of and that's just one example in which forgetting seems to me very evolutionary advantageous.
Mm-hmm. I can just add that to give you an animal, non-human animal example of that, of course, with these birds that hide food, is that they hide thousands of foods. So, for example, one of the jay cousins that lives in America, the Clark's nutcracker, that an individual bird is estimated to hide around 33,000 items. That's just one bird. And remember the location of them. But imagine how much interference there must be if there was no forgetting, because a big advantage is that if they can, once they've recovered the food from that site, they can forget it. Then they won't have interference going on with, otherwise, how do you remember which ones I've hidden and recovered and already eaten, so I don't need to remember those anymore, and which ones have I still hidden and need to remember when I get back. So I think you also have that interference going on in many of the animal minds, of which I'm just giving you a COVID example because caching is such an easy one. But, this phenomenon in general of being able to not have too much misdirection, interference going on in your memories is very important, I think.
Okay, here near the front.
So my name's Kevin. I'm thinking about imagination and memory, and then the way the brain evolves memory physiologically. And I remember an explanation someone once gave me about certain types of phobias. The idea that as a very young person, say, you might encounter some traumatic event about a thing, and then your brain hasn't been able to store that long term because your brain is still evolving or something. And then when you're an adult, if you still have that, there might be a loss or a disconnection with that original thing because your brain hasn't correctly remembered all of it. Is there any influence on, I don't know if that's true, this is what I've been told on that, but is there any comment that any of you can make on the effect of remembering and the integration of memory and imagination as the brain evolves until whenever, I guess, it stops physiologically evolving? I don't know.
Who wants to take that?
Well, the only work I know about is the work of Dan Schachter and colleagues at Harvard, and other people may know more about this. But I know that he certainly looked at the aging brain and how, as people get older, the relative contributions of episodic memory, these experiential memories, versus what is called semantic memory or knowledge-based facts, changes over time. The only other way of answering the question that I know of is that in cuttlefish and octopus, and presumably other cephalopods, but they haven't looked in squid yet, you don't see any evidence of episodic memory loss with aging. Now you could say, well, they don't live very long, but they live longer than mice, and you do see impairments in episodic memory in mice, so it can't just be an age thing. And it's perhaps because they have a completely different type of brain, because rather than having, so in birds and mammals, the hippocampus is one of the areas of the brain that plays a very big role in memory. It's not the only one, but it's one of the hot spots, if you like. Well, invertebrates don't have hippocampi. They have a very different brain. And they have a donut-shaped brain, but they also, most of the neurons are actually distributed in the 8 arms, and it may be something to do with this really distributed circuitry that might explain why you don't see this loss. There are other things as well about the whole way in which the methylation of the RNA works in these creatures that's very different. But I don't think very much is known about it yet.
I was going to say, I got stuck in the phobia part of your question. There is another aspect that might relate to what you were asking. So you can, remember how we were talking about how you can modify certain contents of your memory. So when you reactivate a memory, the memory becomes labeled and prone to modification. And that's typically when people contaminate the memories with false information. But contents, as I was mentioned before, mental contents and mnemonic contents have lots of dimensions to them. They have sensory dimensions. They have what Johannes studies about cognitive dimensions of the content. But they also have affective and emotional dimensions as well. So one line of research, big line of research, is what is known as emotional reappraisal of memories, which is that when you have an emotional memory of, say, a traumatic event, maybe a phobic event, you can reactivate the memory and modify it at the time of retrieval in order to mollify, which is, I like puns, and I think that pun is funny, but most people think it's not. But anyways, I'll keep using it, to mollify as opposed to modify the affective component of the original memory, such that the next time that you remember this negative event, it doesn't hurt as much. And there is work done with emotional reappraisal in phobias, because one way of removing or trying to ameliorate the feelings of a phobia is exposure therapy. So if you're afraid of spiders, then lo and behold, your therapist is going to put you in front of a bunch of spiders. But if you don't have spiders around, one possibility is to remember experiences with the spiders and try to modify the affect that you were thinking of or what you were feeling as you remember the spider. So that could speak to the phobia aspect of your question.
And I just want to add about forgetting memories and not forming less memories as you grow up and don't remembering things. From the engineering perspective, like from building, like taking one step back and building a machine that has the same capabilities, it makes also a lot of sense what you're saying that we see happening in real humans and animals, because you can, at least from our perspective, you can consider episodic memories as snapshots of activities of your brain or your digital brain, right? The more you grow up, you change like the representation of the world, like what neural activations are representing. So when you see something when you're like 2 years old, might mean one thing, but the more like your brain converges to something more like fixed, this representation changes. So if you had the ability to recollect things from when you were like 2 years old, it wouldn't make sense since the activation is different. That is one thing. The other thing is that if we assume that what we record is basically what is surprising, what we need in order to like retrain our brain or use it in different ways, such as don't repeat the same mistakes again, then when you grow up, it's intuitive that less and less surprising things occur, right? And the distance between two surprising events is further. Yeah.
Okay, shall we take a couple of questions from online? It's my colleague in the blue shirt at the front.
So we have one question from Aroni Sarkar. This might be more directed towards Felipe. How much agency does a person have in resisting techniques of memory manipulation?
How much agency? Well, there's a number of things that we can do to try to not forget information. So rehearsal is one of the main techniques, right? We do it all the time. Back when we didn't have cell phones and we had to hold in memory a phone number, you could rehearse it. If you were interrupted, then that was the end of that phone number in your mind. But if you weren't interrupted, if you had the time and you kept rehearsing, that's what we study. So if you, example, to get a hit and run, and you look at the license plate of a car, if you rehearse it, if you focus your attention on that piece of information and you rehearse it over and over and over and over, the chances that it gets encoded and that you won't forget it are much higher than if you are not super focused on the information and paying attention to other stuff. So there is some kind of agency to the effect that there are certain details that you could try to retain in memory and not. I don't know how much more if you weren't paying attention to the thing and encoding, and it is here's what happens. If you weren't paying attention to what the traffic sign was in the example that I was using before, and by the way, this is an example that from Elizabeth Loftus from 1978, very famous paper. If you weren't paying attention to the stop sign, or suppose it was a yield sign, you weren't paying attention to that, and someone asked you later on, hey, did you remember that car failing to stop in front of the stop sign? Your memory system, I argue, probabilistically fills in the gap with what it is more likely to have been there, namely a stop sign. And it comes to you as a full and complete mental content, and then you're gonna say like, sure, there was a stop sign right there. And there is no question, a way for you to questioning it, because it comes to you with self-evidence to the fact that you actually saw it. So there won't be a whole lot of agency there. Rehearsal, I think, is one strategy for agency. I don't know if others, you know more about this.
Yeah, I just wanted to say that a lot of social memory manipulation functions the same way as any communicative manipulation would work, through convincing, through suggestion. And so to avoid that, be skeptical, be on the lookout for that. So a lot of famous memory manipulation studies are studies where people get fully false memory induced and then think that they actually remember events that never happened to them. A famous one is a story about getting lost in a mall as a kid, and the researchers first convince, in each of these cases, the researchers first convince the participant that the event actually happened. And then the participant slowly starts to imagine the event actually by themselves and end up believing they remember the event, where they actually started out with being convinced through all sorts of different ways. Maybe they called their mom and their mom was told to tell them that they actually got lost in a mall or something like this. So this is just to show that at least in the more extreme cases of memory manipulation, but also in some more subtle cases, it works through communicative manipulation first. And it's not specific, it's a memory phenomenon second, so to speak.
Yeah, let's have another one from online.
So this question asks, what biological features would you look for if you're trying to determine whether a species has episodic-like memory, such as caching behavior or complex social groups? I've always wondered that parrots have episodic memory, for example. And that's from Rochelle.
Well, I think you start by looking for cases where you think that they might be able to remember what happened where and when. So caching is very easy in that regard because they hide the food, and then normally there'd be a long delay before they actually recover the food. You've got a case there where you can say, can you remember which kind of food you hid where, and you can manipulate the how long ago with the perishability, as I explained when Ali asked me to explain the experiments. There are other behaviours that you could look for. So in brood parasites such as cuckoos and cowbirds, these birds lay eggs in other birds' nests. And again, you can look at whether they can keep track of which nest to put their eggs in, because if they put eggs into a nest too early, the egg will get rejected, because if the female of the host species hasn't laid any eggs yet and she suddenly sees an egg that's not hers, she'll reject it. But once she's started laying the eggs, she won't notice if another egg is laid. It seems to be a perceptual problem. It's almost like change blindness. You know, you would think that a female would remember that she'd laid 2 eggs and what's that third egg doing in the nest, but they don't. So the timing there is critical. With social interactions, you could look at dominance, for example, and look at whether they can keep track of who was watching, where, and how long ago, and whether that would matter. So it's thinking about behaviours that you could then manipulate to test whether they're actually monitoring what happened where and when, and that what could be a food or a context or an individual those would be ways of doing it.
Okay, shall we have some more questions in the room? Here in the front row.
Great, thank you so much. So yeah, I guess partly I just want to understand a bit more about what episodic memory is. And I was when I was thinking into it was, are there any humans who haven't got it? So I know that you said that really young children don't have it, but are there any adults who don't have it? I'm thinking in particular, like I've heard recently about these people who can't see things in their mind's eye, who can't visualize things. Like if you ask them to imagine an apple, they can't sort of see an apple in their mind. And I was wondering if those people, like if you maybe also couldn't hear things in your mind's eye and so on, you wouldn't be capable of episodic memory, but you might still retain information and maybe be able to sort of date stamp it and place stamp it and function like everybody else. So are there any humans like that who don't have episodic memory?
So yes, there are humans that do not have episodic memory, but one thing that when you study all these neuropsychological cases, one thing that you need to sort of disabuse yourself of is the idea of what I call the switchboard view of the mind. I used to call it the Oliver Sacks view of the mind because Oliver Sacks was a phenomenal neuropsychologist. One of the reasons perhaps why I studied because I loved his stories. So highly recommended, But he presented a view of the mind in which patients appeared as if they had one failure in the mind, as if it was a switchboard that just turned off, but everything else was on. It's like there's this one ability that just got broken, and then the rest of the mind works just fine. And the mind doesn't work that way. We don't have a switchboard in the mind. So one of the most famous patients that lost his episodic memory was known by his initials HM. His name was Henri Monzon, who passed away in 2009, if I remember correctly. He, due to a series of medical conditions and psychosurgeons that got involved, his hippocampi, which is this region that we were talking about that is so important right deep in the miotemporal lobes of your brain, got removed. They were sucked out, actually, in this brutal surgery. But it was a very precise surgery in the sense that the hippocampi, both sides, were removed. And as a result of that, he was unable to encode new experiences. The main neuropsychologist that studied him, her name was Susan Corkin, and he never met her prior to the surgery. So every time the Sue had to go to the room, she had to reintroduce herself. Even though she studied him and was actually the person that paid for his living for the last 30 years or so. It seems as though he was able to learn new stuff, but it is not terribly clear, again, this switchboard thing. So one of the things that is very interesting about him, for instance, is that you would ask him about any event that happened after his surgery in 1957, and he wouldn't remember anything at all. Yet he loved doing crossword puzzles. And sometimes the cues of the crossword puzzles involved, the answers were things that happened after 1957. So how on earth can you solve a crossword puzzle, know who Michael Jackson is, when the surgery was in 1957. So it looks as though he was able to learn some information, some semantic information, in ways that were not really traditional, as it were. So if you were asking me this question 20 years ago, I would say if you have damage in episodic memory, you're not going to have other kinds of learning, because episodic memory is, as it were, the gateway to other kinds of information. Today, I am less sure, in part because I think that the systems are not quite squaring with the way in which we think in our psychological categories.
There are some interesting clips on YouTube of another patient. His surgery, he's still alive, his name's Clive Waring, and his surgery is less clear, but there are lots of interviews with his wife, Deborah Waring, talking about the ways in which, over the years, he's somehow managed to compensate. Mm-hmm. And I think we don't exactly know how he compensates, but he's obviously recruiting other systems to help him remember things. So an obvious example would be that he can't remember that he doesn't live with his wife anymore, but he can look at her face and realise she looks very tired, and therefore conclude that she's not been with him all this time and she must have travelled a long way. So there are compensatory mechanisms like that. There are some case studies. There's a person who passed away a few years ago now called LSE Event, but I think DB is still alive. And these people are particularly interesting because they behave as if they have no episodic memories, and yet they still have the knowledge-based information. So it's almost as if they experience the event third person rather than self-person. So it's not like they remember going to the event themselves, but they can recall aspects of the event. So these things can interact in quite complex and intriguing ways.
Okay, in the middle here, in the white jacket.
Could you comment on how episodic memory interacts with evolution in some sense? I mean,
With evolution?
with evolution, like in sense, if a species learns something to do things in a particular way, like how the next generation might, it could be at a microbial level even, maybe does that information ever pass on to the next generation in the for the organisms?
So I'll just say something.
Yeah.
There are many different types of memory in the mind and in the body. But we have to be careful how we separate different types of memory from each other. So episodic memory isn't just storing or acquiring information from experience. It's the active re-representation of that experience through complex computational mechanisms in the present. And those are personal experiences, right? We are experiencing them, or we're representing them as personal experiences. And so even if it was the case, which is highly unlikely based on what we already know about the computational basis of episodic memory, that there was some sort of transgenerational form of remembering, it would be a different type of representation, right? So imagine I would think I remember something that my mother experienced. That wouldn't be an episodic memory in the same sense that we are talking about, simply because it would be my mother's experience, right? And in a sense, we can actually do that as humans because we can talk to each other. My mother can tell me what she experienced. So other animals can't do that in the same way, at least. But based on what we know about the biological implementation, the function of the system, it seems very unlikely that there is something like the transgenerational transmission of information in episodic memory.
Okay, another question in the room towards the back there in the blue shirt.
Hi. I think, Felipe, you mentioned at the start, you were talking about kind of misperception of memories, and I just wanted to kind of ask, do people misperceive, so thinking maybe specifically about feelings and emotions, do people misperceive memories of feelings and emotions in a systematic way? Is it like, people are kind of looking back with rose-tinted glasses, for example? And if that's the case, how does that impact how people kind of evaluate themselves in the present?
Right, so great question. One of the things that I like to study a lot is nostalgia and feelings of melancholia and nostalgia. Because there's this following thing that happens, which I find strikingly bizarre, which is that I often feel nostalgic about periods of my life that I know I hated. So I hated high school. Like, it was just like the worst experience ever. And sometimes I catch myself going like, oh, remember high school with nostalgia? And like, what is wrong with me? Like, I know that I hate it. I had nightmares about how to do it all over again back when I was in high school. I think that the reason is we have to carry ourselves along through our lives. And and this is another aspect of good forgetting, right? If we carry the same pain throughout our life, if this traumatic or negative events felt as negative every time that you remember them, no matter how much time has passed, it would be hard to carry on with our past. So there's quite a bit of research of what is called the affect fading bias in memory, which shows that as you age, and one way of thinking about it is as the memory itself ages, the affective component changes. Typically, negative autobiographical memories tend to become less negative as time goes by. So the way in which researchers do this, and here perhaps the person that has done the most research is Elizabeth Kensinger at Boston College. She looks at the trajectory of the affective reactions that an autobiographical memory has on the same individual through time. And what she has discovered is that as you age, as the memory ages, because I like to think about it in the term of the timeline of the memory, the negativity of the memory reduces and the memory becomes more positive. Now, interestingly, the same is not the case with positive memories. Positive memories are less bound to this kind of affect, which makes a whole lot of sense. One of the reasons, and this is clearly dovetails with something that Johannes has done a lot of work on, is that we tend to remember good episodes more than we tend to remember negative episodes. And the reactivation and the constant positive reappraisal of autobiographical memories that are positive tends to keep the positivity of the emotion alive, as it were. And also there is a downside to that, of course. If you tend to ruminate in a negative aspect, like a lot of the research that we do in the lab is with individuals with generalized anxiety disorder with and without depression, that they tend to have repetitive counterfactual rumination. That is, they imagine constantly regret-producing memories. What we see is that actually their negative memories don't fade toward a more positive, but rather they flatten out in this very negative feeling to it. So, long-winded way of answering, yes, there are distortions of affect that occur in your memories as a function of time. Those distortions, as many of the distortions that we have talked about here, are extraordinarily adaptive.
One thing to add maybe would be that this is actually a relevant aspect for considering the ethical implications of whether other animals have episodic memory and of the same kind or a similar kind as we do, because our memories have this valence to it, so they feel good or bad, right? And so if you have that capacity, suddenly every single experience that you have that is valenced is multiplied by, in its sort of ethical welfare impact, by the times you can retrieve it in the future, right? So if other animals, which is highly likely, have valenced episodic memories, so can remember feelings of pain or pleasure that they've experienced before, we should maybe be even more careful of causing these experiences to animals in the first place, because they are multiplied by their capacity to retrieve them again.
Well, and I'd just like to add in that regard that together with my postdoc Alex Schnell, and the lead on this was LSE Professor Jonathan Birch, we did actually change the animal welfare bill with respect to valence of episodic memories, particularly for the true decapods, the crabs, and the cephalopods, the cuttlefish and octopus and squid.
Okay, another question in the room, just on this side, halfway up. Yeah.
Thank you. My name is Andy. Currently, whether or not certain animals or AIs have consciousness are still being debated. Dr. Fountas mentioned that certain artificial intelligence models have displayed memory capacity. Would consciousness be a prerequisite to memory, or are they distinct from one another?
That's a really hard question. I don't know. There are many ways, I guess, to define what we mean by consciousness anyways. There is, first, even in terms of memory, there is the autonomatic consciousness and anoetic consciousness and all these things. I would say that not so much about the ability of it's not so much about the ability of remembering things, but the ability of forming memories that seems to be related with consciousness more. It's really hard to say like to what extent that would mean that having an ability to form memories implies conscious experience or not. But all I can say is that, to my mind, like the only things that we can argue about having consciousness are the only time instances that we can argue that we have consciousness are the ones that we record in episodic memory. And it would make sense from an engineering perspective that this ability to unify experiences together from various parts of the brain and have this sense of self recorded into a specific event is very closely related. But I mean, I don't know like what you guys think, but I tend to avoid thinking about consciousness.
I think it relates to a thing that Nikki was lamenting about being able to test episodic memory in other animals, because traditionally one of the defining features of episodic memory in the field has been a phenomenological one, a type of consciousness that goes along with being able to remember. But I think in general, as good scientists, we should try to find ways to measure and look at cognitive systems that talks about their behavioral and informational functions. And so I think we can do that with episodic memory exhaustively. We don't actually need, I think, phenomenological criteria. So I would say, if we understand episodic memory fully, we will also be able to understand whether a system has episodic memory or which aspects it has without having to resort to phenomenology or consciousness.
Yeah, I would. So I have a love-hate relationship with research and consciousness. It's like I have written about it and then I tried not to think about it. There is one sense in which we are perfectly okay with not knowing what it is like to be another person. When a loved one dies and you tell the story to someone, you typically hear the answer like, I can't even imagine, right? We're often okay with not knowing what it is like to be in a particular experience with another individual. Imagine that 24/7 with another creature, right? It's not that strange to know that we can live with other people thinking of them as having experiences without really knowing what it is like to be aware of knowing what that experience is. So somehow that thought had helped me to demystify the what philosophers call Mysterianism about consciousness. But then there is another aspect in which you think, well, research on consciousness and intersection with autobiographical memory is not really that impossible or preposterous to think that we can solve it. Because, as Johannes was saying, well, if consciousness is produced by some mechanism in the brain, then let's figure out how humans, what is the mechanism in the brains of humans, and we have fantastic researchers that are doing work on that, and then try to figure out, just as we think, that the hippocampus is required for relational information in episodic memory, let's try to figure out if those very same mechanisms or predecessors of those same mechanisms are in other non-human animals. So on the one hand, neither of those aspects, my bottom line is, neither of those aspects should generate the feeling of Mysterianism or like being super mysterious that this consciousness is. We live happily without knowing what it is like to do a bunch of different things. And also we live very happily trying to figure out what it is, what are the underlying neural mechanisms and all sorts of cognitive faculties. Why wouldn't we do it with consciousness as well?
Can I just clarify something from what I meant before? So I really think that it might be the case that we never learn how it is, as you said, to be like each other. And since talking about consciousness might be just a language construct in the way that we talk about it, we might very well, I agree that we might find how these mechanisms work that create the behavior of us talking about it. But what I try to avoid is thinking like whether this is there's anything more than that, because I think that it's just playing with words, pretty much anything more than like the mechanisms that create this behavior. Yeah.
Okay. So I think that brings us to the end of our time, unfortunately. I know there's more questions in the room, and I could definitely carry on talking about this for a lot longer. But we'd better let all of these good people go, and all of our speakers have a rest. So thank you very much. It's been a great pleasure to have the chance to talk to you today. Thanks to all of you in the room and online for your questions and for joining for this event. I should mention this event is part of the LSE's Philosophy Live series, which is a series of events. And if you're interested in finding out more and coming to more public philosophy events, you can search for LSE Philosophy Live. I think our next event in the series is going to be in October on the subject of Taylor Swift and philosophy. So do come along for that. But for now, I'll just thank again our speakers and all of you, and wish you a very good evening. See?